Right. Good. Good. Hope everyone's okay with that. Okay, it's 4 o'clock. We'll give it another minute or so.
Yeah, I was trying to find the raise your hand button on my Zoom. Maybe I don't have the newest app, but I saw people using an app where they hit a button and it raises your hand for a Q&A.
At least on my version, on the bottom of the screen, there's actually a heart symbol that says react. And if I click on that, it gives me a lot of emoticons.
If I just raised my hand, that was an accident. I didn't. I see what you're talking about. I just don't. Oh, raise hand. There. Oh, look at that. Thank you. I'll raise hand. All right, I'm going to give it a shot. We can
There you
ignore it.
go.
I think I raised my hand. No,
Sometimes it's easier to just say, "Hey, Gary."
I know, but but there's a couple. But on the smaller calls, I just hell out. But well, there's like 30 people on the call.
Yeah, yeah. Some people are just born naturally polite.
All right, well, it's 4:01, and in the interest of keeping our meeting on schedule and uh, in deference to all those who are here on time, good afternoon, everyone. Welcome to the very first HamSCIence Telecon of 2026. It's January 8th, 2100 UTC, and it's good to see so many of you here. A few new faces and many returning faces both. Both are always welcome. So I think I'll get right into introducing our speaker today so that Barry can take over because he's really the one you want to hear and not me, I'm sure. So today we're welcoming Dr. Barry Johnson, a longtime faculty member at Alabama A&M University. Barry is a prolific author and a U.S. patent holder, having worked on many topics in the realm of physics, including optics, telescopes, and digital imagery over the years. Today, he brings his long-standing ham radio interest to the HamSCIence Zoom session, speaking on WSPR and its ultimate capabilities. Or as my engineering brain, I like to put it, you can't trust your data if you don't understand the limits of your equipment. And I think after today's talk, we should all have much more confidence in our investigations which are based on WSPR data. It'll be all a good thing. So I'll be running the slide deck from my computer today. So please give me a minute to get the screen share going. And as soon as I do that, I'll turn it over to Barry and we'll get started. Barry, you can tell us if you want us to ask questions during or if you want to hold them to the end. That's entirely up to you.
Let's just wait till the end.
Good, good. That seems to work pretty well. All right, let me work on my screen share. And that should be your first slide showing for everybody. How's that look?
All good
Looks
here.
good.
All right, great. Okay, Barry, the floor is yours. I will mute myself.
Okay. Thank you very much. I appreciate everyone coming, and I'll, pardon me, try to make it interesting and also not very long. But how narrow is narrow enough is an interesting question. Pardon me for just a second. WSPR began life as a propagation beacon mode, but over time, it's become something more than that. It's become a scientific measurement tool. Once we start using WSPR2 for such things as Doppler studies, frequency stability, and fine scale ionospheric dynamics, the spectral width of the transmitted signal becomes a first order parameter. This talk addresses a deceptively simple question posed by Dr. Gwyn Griffiths. Good to see you on there, Gwyn. What is the minimum obtainable spectral width of a WSPR2 signal? As you'll see, answering that question turned out to be anything but simple. Slide. Change slide, please.
Let's see. I'm working on it. There we go.
Okay.
Nope. I gotta change my settings here. Sorry.
Okay.
View single page. There we go. There you go.
All right. Thank you. I want to give you a bit of a roadmap right up front so that you'll know where I'm heading. Under controlled conditions, we repeatedly measured a baseline spectral width of about 11 millihertz on 40 meters. The dominant contributor turned out to be transmitter reference stability. Receiver stability matters, but much less. And unexpectedly, the choice of reference frequency driving the Silicon Labs SI5351 itself plays a major role. And finally, and this is important, algorithmic precision, not hardware limits, sets the true floor. Slide. At first glance, this sounds like an easy problem to address. You transmit a whisper-to signal, you receive it, and you measure the width. But what you're actually observing is a combination of transmitter behavior, receiver reference stability, propagation, and co-channel interference. At millihertz resolution, even very weak nearby signals matter. The core challenge of this work was figuring out how to isolate the intrinsic transmitter width from everything else. And I should have mentioned up in the title there that Gene Marcus was intimately involved in this whole activity and is a longtime Whisper-2 activist. Next slide. We began with over-the-air measurements on 40 meters. From my QTH or home in Huntsville, Alabama, we had access to two useful paths. One was a 10.3 kilometer clear line of sight path to the National Space Science and Technology Center building located on the campus of the University of Alabama in Huntsville, shown with the arrow there. You can also see the Saturn V standing up. That's a one-to-one mock-up of it. It stands 365 feet tall, as I remember. Quite a beautiful view from my home. The other was to Gene's station, W3PM. It's a 27-kilometer path, and it's partially blocked by two mountains. Both transmitter and receivers were GPS disciplined oscillators referenced, and we fixed the transmit frequency to remove any hopping effects as a variable. Slide, please. For over-the-air measurements, we used the Zactec Whisper transmitter shown in the lower left. This is a prototype that Harry SM6PNV provided that allowed selection of the internal TCXO or an external reference. On the right side is shown the Bodner GPS disciplined oscillator we used. The antenna utilized was a Cero Mazzoni baby loop, 1 meter in diameter. The second Zactec transmitter was used with its internal TCXO reference and was attached to an Alex loop to provide simultaneous measurement of the two signals to observe the impact of the reference. Pardon me. Under quiet conditions, both paths produce essentially the same identical spectral widths, about 11.2 millimeters. This was an important early result. It told us that moderate terrain obstructions and path length had negligible influence on the measured width. When the band conditions are quiet, over-the-air measurements can get surprisingly close, we found, to the intrinsic transmitter spectral width. Slide, please. The trouble began when the band got busy. Spectral width suddenly became random and inflated, sometimes dramatically so. Using Dr. Gwyn Griffith's Whisper Demon co-channel analysis tools, we found intermittent, closely spaced signals contributing energy inside the decoding bandwidth. These signals are often not obvious on a casual waterfall inspection, but they can cause trouble at the millihertz resolution. This is the point where we concluded that over-the-air methods are not reliable for establishing minimum spectral widths on crowded HF bands. Slide, please. To isolate intrinsic behavior, we moved to a direct connected configuration. The transmitter was connected directly to the receiver through a shielded precision attenuator system. No antennas, no propagation, no external interference. What remained were the transmitter, the receiver, and their reference sources. Slide, please. With the GPS-DO references on both the transmitter and receiver, we measured spectral widths on 40 meters was consistently 11 millihertz. This value was stable over time and reproducible. We treated this as the practical baseline spectral width for this class of GPS-DO-based Whisper 2 systems. Slide, please. This slide shows one of the important results of the study. You can see that the table. The TCXO receiver increases the width modestly, but a TCXO transmitter increases the width by nearly an order of magnitude. For experiments where spectral width matters, it is far more important to know whether the transmitter is GPS-DO referenced than the receiver. Slide. Thank you. The SI 5361 datasheet recommends reference frequencies in the 25 to 27 megahertz range. In practice, we found that 10 megahertz was significantly better. And more surprisingly, 4 megahertz was better than everything else, sometimes by more than a factor of 5. This told us that the reference frequency, this told us the reference and frequency selection is a real design parameter, not just an implementation detail. Slide, please. Thank you. Frequency hopping is useful operationally so that you don't interfere with other people and such, but it comes at a cost. The PLL relocking and settling introduce additional spectral spreading. With a 4 megahertz reference, fixed frequency operation averaged about 13.3 millihertz, while hopping averaged about 18.2 millihertz. That's roughly a 37% increase. For minimum width characterization, fixed frequency is clearly preferred. Slide. What does not matter? Several intuitive factors turned out not to matter. Changes in signal-to-noise ratio of up to 20 decibels had no measurable effect on spectral width. 16-bit versus 32-bit microcontroller units made no difference. The limitation is not hardware capability, it's algorithmic intent. Next slide, please. And I'm glad to see Paul's here because we had several very enlightening conversations on this point. Spectral widths we observed are not fundamental limits of Whisper 2. Using carefully constructed lookup tables, Paul has demonstrated frequency setting errors well below 1 microhertz. And that was, I believe I'm correct in saying this, Paul, that was a non-exhaustive look for the frequency, the set of coefficients that would provide that level of performance. Is that correct? Yes.
Yes, well, actually with the Whisper Sound, it's pretty just plain algorithmic. It was an exhaustive search for ratios that provided the frequency shift value. But once that was done, it was pretty exhaustive to find those ratios, but then after that, it's just plain math. The same ratio holds for any given band range, essentially. I can go into more of it later if anyone's curious.
All right. Thank you, Paul. Yes, and I was very grateful that he did that because I was about to start doing that with a little small supercomputer I have in my laboratory to do an exhaustive search. And that would have been wasted effort. So and also whether you use integer math, floating point math, continuous fractions is a secondary issue, as long as you allow the algorithm to converge to sufficient precision. This reframes a problem really from a hardware limitation to a design opportunity. Down at the bottom, you see the whisper song, and that's a beautifully designed unit. And that's mine right there in the picture. And up on top of it is the 9-band combiner of the outputs so that you can have a single RF output. And I'm in the process of refitting my old Gap Titan antenna. It kind of needs to be refurbished. And when I get that back up, this will be it'll be used for the antenna for the beacon on 8 different bands, and be doing both Whisper and FST4W. Since we have them both on that. Next slide, please. For HamSCI, the most important question may not be how narrow Whisper 2 can be, but how narrow does it need to be for specific scientific objectives? These results, we hope help to find realistic lower bounds. The guide transmitter designed for Doppler and frequency stability studies. And they improve confidence in the interpretation of ionospheric dynamics derived from Whisper 2 and FST4W data. It is very important to have knowledge of the transmitter performance capability to have confidence in the generated data. Having knowledge of the receiver configuration may also be important in some experiments, but to a lesser extent than knowing what the transmitter is doing. As Whisper 2 continues to evolve as a scientific instrument, understanding these limits becomes essential. And I think that is what Paul has done is removed essentially the spectral width if you have the proper reference, like a Bodner reference, and you can have confidence that the transmitter end is not the issue. It's whatever else is there, the co-channel interference or what have you. And last slide, please. And I'd like to thank Gwyn, Paul, and Harry all for the help that they gave us during this study. And it was an interesting adventure plowing down through the path. And thank you both very much.
Okay. Excellent, Barry. Thank you very much. And thanks to all the others too, who assisted in working through the study. What kind of questions might we have for Barry?
Yeah, 1 second. I had a question and I just need to go back to where I jotted it down. But basically, you were commenting about for the oscillator reference that 4 megahertz was better than the recommended 26, 27 megahertz. Oh, here it is. Did you measure the CW or unmodulated output of the transmitter to look at like the phase noise response to see if the phase noise was changing with the different reference frequencies?
No.
Okay.
I have a comment and perhaps a question about that reference frequency into the 5351 issue.
Uh-huh.
And Barry, maybe you can confirm my understanding here. When you were doing those measurements, I believe you were using, well, yeah, you had to be using the Zactec. With the 5351, pardon me for my coughing, as you reduce the reference clock frequency, the available intervals, the frequency resolution gets better and better as you reduce that clock, the reference clock. And the Zactec was picking its phase shift values using that reference clock, knowledge of the reference clock to pick its dividers. However, in the Zactec, the divider selection, well, it kind of limited the resolution and therefore the accuracy or the match to the actual defined whisper FSK amount, the 1.6 hertz or whatever it is.
So the step resolution, you mean?
So I think it is that the step resolution got better. Now,
Okay.
if you're using, like in my design, I'm using 10 megahertz, one of the process that Barry was talking about, coming up with those divisors, I was able to pick divisors that gave me either exact or, within a couple microhertz of the FSK values. And I believe, the desired FSK values. And I believe that with that type of divider selection, it really doesn't matter what the actual reference clock is going into the 5351. As long as you can pick the dividers. So I think the real issue is how close can you get to the desired FSK shift value. And measurements that we've done with 5351 does show actually phase noise improvement as you increase the reference clock.
Mm-hmm.
And as you might expect, given, the phase-lock loop and the filter design internally, it's not significant in these, types of whisper measurements we're doing, but it is measurable if you look hard enough. So anyway, Barry, I believe that's what's happening with the reference clock
Well,
issue.
that's part of it, Paul. The other part is that uh, the way Harry is doing it in his code is he only resolves it down to 10 millihertz, and no matter what no matter what you put in, it's not going to come out much better than that. And and we didn't feel like rewriting all that code to try to, because we were going to have to do it with do the exhaustive search. And
Yeah, so my point is, I guess, that the improvement you saw is still, it's based on how closely the transmitted FSK matches, what the receiver is looking for in terms of
exactly,
FSK shift.
exactly.
Okay. All right. That's interesting. Okay. Well, thank you.
You're welcome. Thanks, Paul.
Sure.
Yes, Gwyn.
Barry, thank you so much for, with enthusiasm, with you and Jean to take up answering what, as you said, appeared to be a simple question, but many of the things that you and Jean have uncovered were quite a surprise to me. They were unexpected. It was not really well trodden. And so I was also glad to hear some of Paul's contributions this evening related to his studies. One factor that still does puzzle me, and as you know from our recent conversations, the asymmetry between the effect of having a TCXO in the transmitter and in the receiver. I was hoping that somebody else on the call might shed some light, and I see Paul's hand's gone up.
If someone else wants to take this one, please go ahead, but I'm pretty sure I know why this is the case. I've seen it. The reason is that the transmitter, when it starts transmitting, it gets hot. And that affects even an excellent TCXO will shift its frequency somewhat. Whereas a receiver, it pretty much, once you turn the thing on, it gets to whatever its nominal operating temperature is, and it's pretty much stays there. So there is much less frequency shift in a receiver than in a transmitter that has a TCXO sitting on the same board right next to its power output stage. And that's all it is. If you were to take an external TCXO and plug it in, I believe there'd be no you would not see that discrepancy, that difference.
Okay. So
That's my theory, but it's also, those are my measurements because I've done it.
well, as with all theories, it can be tested by measurement, and as you suggest, the external TCXO might be an option, and allied to that, really, then is the fact that as a TCXO for a mean frequency, the shifts that we're seeing would be absolutely tiny and not measurable by the average person. It's when one looks at widths that it emerges.
Yeah, widths or other measurement techniques. If anyone's interested, ask me about frequency, long-term frequency stability with the various Bodnars. Gwyn, you've seen some of our email in the last couple days. Interesting stuff. But that's not. This is not significant enough of an issue for the type of measurements that Barry's doing, or the spectral width, which also, that is the measurement of the spread, correct, rather than the, standard RF occupied bandwidth, which is something completely different, if I'm not mistaken. But the spread as reported by FST4W, for example, those receivers.
Another possibility for reference for the transmitter might be an ovenized oscillator, which probably would be similar to a GPSDO.
And yes, I've used that ovenized. You can get cheap ovenized oscillators.
Yes, you can.
It's just, if you care about, millihertz transmit frequency accuracy, it may take a while to get that tuned right on frequency.
Well,
but stability wise, it's excellent. Probably
you
better
have
than
the same
the
problem
Bodnar.
with a TCXO, even more so.
Yeah, but OCXO is probably going to be cleaner signal, less drift than a Bodnar even. As far as
the
phase
Bodnar
noise.
just has a TCXO in it. It does not have ovenized in it.
Correct.
It's not really that clean in that way.
Right. It's clean enough for these measurements, but there is a difference. Yes.
One question I had on the transmit side is when you are transmitting, you're creating greater current demands in the overall circuit board due to, just the current consumption during the transmit period. And I just wonder, is it also possible that just variations in the regulated voltage are just more pronounced when you're transmitting, causing the TCXO to move around a little bit more, as opposed to a receiver where the load is essentially constant?
That's certainly a possibility. I don't know if Barry's looked into that or not. I do know that at least in the couple transmitters I've looked at, and these are things like the QRP labs, they're, I forget what it's called. I got a couple of them. Anyway, the thermal issue was by far the greater one than any power supply variation. But oscillators will be affected by voltage, that's for sure.
Yep. Paul, one of the things that, and David, is that we allowed the transmitters to be, I let them to be in the sun, and get hot. Then they went in the cold during the night, And this was hot was at that time probably mid 70s, and cold was down in the upper 30s, low 40s. And also I kept the transmitter inside in my garage, which stays strangely about 55 degrees year round. I haven't figured that one out yet. But anyway, we saw really no obvious difference between the two. And
If I'll put something on the screen in a bit once I find it. If anyone wants to see transmitter drift due to temperature on a TCXO, I got some on my website measurements I've done. But don't let me, guys. Questions for Barry, please. I'll be looking at this for a while.
Any further questions for Barry? Turn that off briefly. One humorous thought I had is Barry was talking about the calculations for the SI Labs chip, whether we use Paul's algorithms or the local supercomputer. That sounds like a basis for a new reality show. Paul versus the supercomputer. Something we could maybe do a Dayton up on the stage.
I'll put my money on Paul.
Okay, let's see if this shows up. Got it, my screen. Can you guys see what I'm showing here, this plot?
Yes.
Okay, this is an FST, I think it's dash 1200 or 12 or 300 perhaps. But this is the drift, and a whisper receiver will track reasonable amount of frequency drift. An FST4W, the decoding software does not track drift. So once it drifts more than a symbol width, this is a completely non-decodable signal here. But this is over, I think this is over a 2-hour period. This is the frequency versus time of one of the QRP Labs transceivers running a long FST4W. And again, this is all due to the TCXO drifting. I'll close that. But anyway, so it's possible to measure, and this amount would completely, if you could even measure spreading on this, it would be really, really bad. And I don't know if you're curious. I think I got a picture of. Yeah, here we go. And I'll share this one as long as we're all here. This is something like this one. Okay. This is like 2 frames of FST4W dash, I think it's 1200. Uses the FSK. Anyway, but this is with the GPSO instead of a TCXO, sitting on the board right next to the transmitter, the power transistors. So, it's possible to send, but this is just the difference between oscillators. Okay. I've made a study of oscillators and their interesting behaviors. It's a lot of fun.
All right, great. Anything else for Barry? Well, thank you very much for the enlightenment. I think we've all learned quite a bit and have something to think about as we hopefully more and more of us get involved in some of these Whisper 2 studies. One HamSCI commercial I guess I would like to give for a second. Let me put something in the chat. If maybe you're not familiar, HamSCI does have 10 of, let's see here, 10 of Paul's whisper signs that we would like to deploy in relatively specific locations around North America. And at the current time, while we have the whisper equipment in hand in Scranton, some of the incidentals, the cables and power supplies, and probably the GPS DOs and stuff still have to be obtained. And there's also a case of the labor needed to document and assemble all this stuff and get it ready to be shipped out. But if you would be interested potentially in running one of these whisper sondes and contributing 8 bands worth of whisper data to the overall database on a 24/7, 365 basis, and you're near some of these locations, we do have a hosting interest form on the HamSCI website. So please throw your head into the ring, name, email address. We're not collecting a whole lot of information, but you never know. We like I say, we've got grant funds to deploy these units, and we just need a little more time to get everything together.
And if you want to host a whisper sonde, it does not take much. Once you get the antenna hooked up and everything running, it's pretty much just plug and play. You configure it, you turn it on, and it runs. We've got them running down in Antarctica, and yeah, Pierre, hi Pierre, pretty much close to the North Pole, and all over the place, really. And so anyway, so it's easy. So just don't be shy. Talk with Gary about getting one. It's kind of a lot of fun.
I think one of the antennas commonly used are like an 80-meter end-fed half wave, if I remember correctly.
Yeah, that loads up really well on the 8 ham bands that we're using. All of the ham bands from 80 meters to 10 meters with that antenna, with the exclusion of the 30 meter, the 5 megahertz or 60 meter 5 megahertz band. But there are 8 other ones that we do transmit on, and that antenna it's easy. It works. Very happy with it.
Yeah, I think that's the antenna that HamSCI will be supplying for the grant funded units.
Yeah. Gary?
Yes.
Gary, I'm going to be using I've got my own whisper sonde, and that was the intention, as I told you, to go ahead and join in, provide this when I get it up and running. But I'm using a Gap Titan vertical, and it's that will be a little interesting difference between using the in-fed and having the vertical.
Yeah, and Barry, if you have any issues with getting a good match on any frequency, there are multiple ways we can either improve the match or, throw an attenuator in so throw away a little bit of power to improve the match that way. Just
Right.
let me know. Happy to help you
Okay.
work it out, and love to hear your experience with that antenna too.
Yep. I will be happy to share, of course, with you, Paul. I just got to renovate it now. It's been up for 30 years.
And Paul's being modest too. The company he operates, Turn Island Systems, it's also possible to go there and purchase one of these units and the ancillary components and stuff to get most of what you need to get one on the air too. So that's certainly many folks have done that too. So that's also an option.
Yeah, I mean it's basically run out of my garage, but we try to make it look good. And I'm pretty proud of it. So thank you, Gary.
Mm-hmm. And if you're the Dayton Hamvention, come and talk to Paul too. So that's another benefit. So, all right, Barry. Well, thank you very much. Well, I guess we'll close that part of the program. Obviously, you're welcome to stick around. Somebody may still think of a few questions and stuff like that. Is there any general discussion or questions about HamSCI or any of our projects or various activities going on at the moment?
Thank you, Gary, for the opportunity. I'll go ahead
Sure.
and dig out.
Appreciate your efforts. Oh, Travis has got a hand up.
Hey, Gary. Yeah, my name's Travis. I'm in Missouri. And I ran across the Whisper HamSCI projects recently. And I am interested in participating and contributing some data. I live out in the middle of the woods, a very quiet environment. I did send in my information earlier on that web form. I sent that in earlier today with my grid square and all that. So looking forward to hearing back and seeing if there's any way I'd be able to help out.
Very good. Thank you.
All right.
Yeah, just to give maybe a kind of a brief update on the personal space weather station. Of course, there's 3 or 4 main components, I guess I would say, one of which is the RX-88 Whisper Demon SDR receiving system. And we've probably got maybe 8 or 10 of the RX-88s in Scranton. And one of Dr. Furcell's research assistants is currently going through and documenting how to basically load all the software and get one of those systems running, how to build the antenna, so on and so forth. Just documenting the whole thing very thoroughly. And when we do that, then I think hopefully by spring of this year, we'll be ready to deploy some more of those receivers, which are receiving, doing the Doppler shift reception, whisper reception, and so on. So that's the one receiver. The second component is the ground magnetometer. Likewise, that design is pretty stable. And there's a team at Scranton with Rachel Furcell, Dr. Zakrzewski, and Mohad Makhtari in the engineering lab that are working on documenting that as well, so that we can build more of those up and then send them to people and they have the proper instructions and stuff to install them. And then the VLF receiver and reception devices, I haven't heard an update on that recently, though I'm sure that Jonathan Rizzo is working hard on getting that going. And as I said, the Whisper transmitters, many of the most significant components are available in Scranton. What we're learning is that sometimes your eyes are bigger than your stomach. We've got all these projects, and you need a fair number of people and a fair number of hands to actually make them happen. And slowly but surely that is going on. So though I thought many of the folks that have filled out some of those forms with a hosting interest, whether it's transmitters or receivers, it may be a while since we've gotten back to you, but believe me, everything is still in line, and I've not heard any, hopefully there are no negative repercussions from the way the United States has chosen to fund or not fund scientific activities this year. So hopefully everything will keep moving forward. So a little bit of an update. Yes.
I'm sorry, but if people are hosting any of these transmitter and or receiver systems, does anybody have any stories to share about being able to conduct normal ham activity? I'll use normal ham activity, you know, if you run an FT8 or sideband or whatever, co-located with any of these systems. I'm just curious about any co-site interference issues or trying to coordinate things where maybe a system is not active or whatever while other things are being operated. You know, I'm thinking if you got a receiver running, but somebody's running a 100-watt sideband or whatever, I could see something like on some of these receivers being overloaded unless they have some sort of front end filter to them or things like that. So just curious if anybody's got any experience in that. Because like I said, it's something I may be able to help out with some capabilities there, especially now that I got internet service that's reliable. And one of the things I do have one of the magnetometer kits that I've held off actually putting together until I finally got the internet service at the end of December 30th. So anyway, so I'm hoping to get that assembled and actually deployed. So
I've got some experience with the transmitter receiver interactions. For example, with the whisper sound, we're putting out 1 watt on up to 8 different bands simultaneously. With a typical SSB, transceiver receiver, the filters are good enough, that, unless the antennas are right on top of each other, it's not going to really screw up your reception. There may be some birdies that pop up, but it's not too bad. If you're using a wideband SDR as a receiver, that will affect your dynamic range and possibly have to crank down the gain and you'll lose some sensitivity, especially at the higher frequencies. The whisper sound can be, I've got a sort of a cron style configuration on the thing, so you can tell it to, only transmit during these times or not transmit on a given frequency at a given time. So you can tailor it that way. Although for science, it's best to obviously have it running all the time because you never know what's going to happen in the ionosphere. I'm not much of an operator, so that's been the limit of my experience. Maybe somebody else has more info on that.
Okay. All right. Well, I have to think about things, but like I said, I've got to do baby steps. At least I've got an internet connection now. So I first want to try and get the magnetometer in the ground. So that's going to be my first step. But I could never do anything without a reliable connection. So at least I got that now.
One thing I could mention that K3LR, the big contest station in West Middlesex, Tim basically shuts down his PSWS on Friday afternoon on big contest weekends because he's running 6 bands, 1,500 watts with antennas pointed in every conceivable direction. And then he turns it back on Monday. So there's a gap in the data, there's a gap in the data. At least we're getting a whole lot more the rest of the year.
I can speak to our experience at VY0ERC.
Sure, Pierre.
Yeah, so there we often have operated with some hundreds of watts, and the receivers haven't been impacted by that. We do hear the transmitter via intermod, I think, on several bands. But again, if we're doing something like a contest, then we just turn off the transmitter for the duration of the contest.
Okay.
Are the antennas, are they wire antennas? Are they orthogonal, ideally placed, or do you not maybe have a whole lot of choice on where things go?
We don't have a whole lot of choice because there's nothing to hang antennas from. So at one location, we'll run something like a spider beam Yagi. And it's a Zactec there, and it has a NFED, which we hear quite well from close by. At the other location where Paul's whisper sonde is, it's unfortunately only 3-band, kind of a fan dipole setup. And we can hear that largely around the bottom of 14 or 20 meters and 17 meters. And it's running on 10, 15, and 30, I think.
Now, the whisper sound is some distance removed from your receiver site, though, correct?
From the whisper receiver site, yes.
Okay, you have other receivers then.
Yeah, well, it's a long story, but we've lost consistent access to the facility that we were originally using. So I've moved some of the ham activity to the other one, which is closer by, and so yeah, now they're close together.
Okay.
Safe to say, though, that Pierre is still the northernmost personal space weather station activity in the world, I'm sure.
Yeah, 80 degrees.
Wow. Yeah, I mean, I kid around. Folks like myself, we complain about being in an HOA situation, but at least we're not so far north that there's no trees and no vegetation. That's a different situation. John, you had a question or an input?
I did. Thank you very much. All right. It's going to take me a while to kill my feedback. All right, there we go. Sorry, I'm on 2 machines. I had a question on antennas. When we talked with the Dr. at Cornell, he said we can do this with a coaxial loop. And at my house, I just have end-fed half waves, which will work fine. But my question is, on the materials on the HamSCI website, you have all the equipment spelled out, and then you have an antenna recommendation, and the antenna recommendation, it says, to come or to be updated. So I am looking for antennas at Penn at the university where we can stick an antenna indoors. We already have a coaxial loop, and we can do fan dipoles indoors because we already have the office space with Professor Smith's office. But do you know if when and if that update will come on the HamSCI website about the antenna recommendation you guys are making as a group?
Is this for the RX-88 Whisper Damon receiver, or which component?
This was on the, and I can find it for you and email you, but for the personal weather station on your, you have the equipment list, and it's very similar, and it has the antenna recommendation, and it says that the antenna recommendation is being developed by HamSCI.
All right, if it's, I think I may know where that's at because I may have been the one that wrote that, and I should probably update that to show the probably the DX Engineering active receive vertical, because I think that's what we're going to standardize on the PSWS is what we're supplying with the grants. I know Rob and others were working on a lot of studies, particularly over the summer on different options, and right now, at least the DX Engineering one is the most easily obtained because it's commercially available. So I probably should take a look at that, John. So thanks for the reminder.
Wonderful, yeah, and I'll look for that for DX Engineering because we have ham radios, we have antennas, and and we have some budgets for this on Penn's budgets. So thank you.
It's always tough on a college campus too because the noise levels are so high. I mean, where I went at the case. Between the university and the two major hospital systems are all co-located. It was a mess, but such is life.
Tell me about it. They ripped our antenna towers down twice. We have towers on the Moore roof, and they ripped them down in the 80s. We put them back up. They ripped them down twice. So we do what we can.
Perseverance is key. All right, we're getting near the top of the hour. Any other comments or discussion? All right, well, I'll throw in one advertisement for next month's HamSCIence talk, which I believe will be, should be February 8th. We'll be speaking about precision GPS, how it's used, and some of the implications when the signals go away from severe storms like during the Gannon storm of about a year and a half ago or so. We'll get the details on that on the HamSCI Google group soon. So we will be having definitely a meeting and a speaker next month. All right. Anything else? Any other comments? Otherwise, we'll close her down. I'll stop the recording and we'll call it a week.
So let me thank you, Gary, and everyone. This has really been instructive and entertaining. I appreciate it.
All right. Oh, Ed, you had a question. Yes. Let me think about that.
Just a quick question. You're mentioning that you're running a regular thing every month. Are we reducing this conference to once per month, or is it going on every week?
The formal speakers are once per month on the second Thursday, and on the in-between weeks, we've kind of had an informal net. We've just opened up the channel, so to speak, and kind of let the ideas flow.
Okay, that's great. I just had that question because during the Christmas holidays, I wasn't attending, and I didn't know if there had been a change. Thanks.
Also, one more commercial, of course, the HamSCI workshop is coming up in the middle of March. All the details are on our website. Well, most of the details are on the website. As Ed pointed out, we've not made any hotel recommendations. The workshop committee is meeting Monday morning, very early, and I hope to have some of those recommendations come out of that meeting on Monday, and then we'll be able to publish them. So though the details for attendance and for sign up, the location of the meeting are well known. We're working out the hotel stuff, I believe, as we speak. Yet to come. All right, everyone. If that's it, thanks all for attending. Let me stop the recording, and we'll call it a week. Everyone have a good safe week, and we'll speak to you soon.
See you. Bye bye.
Thank you.